So today we have a K7500. I don't know if it's a 25 inch, 27 inch, doesn't matter. They're both the same. Only difference is the little pin cushion board that I've got one right here, little pin cushion board that hooks right there. This did not have it, so I can only assume it's 25, but doesn't matter. It works fine on 27 even without that board. But anyway, this is one of the chassis that I've got in 3 giant tubs and a bunch sitting over here off camera in a stack in front of the parts closet over here. So I just grabbed it at random and I thought, well, it's time to start going through all these. I got probably, I don't know, 50 of these chassis sitting, not this particular one, but 50 unknown condition, needing to be looked over, ready to start working on type of chassis sitting in these tubs and off camera and in the closet and stuff. So I grabbed the first one on the top of the pile, and it's a K7500, and it's missing the flyback. It is missing the B plus pot. It has had a rudimentary cap kit with just caps on this side. They did not do this cap, did not do that cap, did not do the bipolar cap. They robbed the flyback for something, I guess. So obviously this must have had problems, and they robbed the flyback for something else. There are a number of issues, like for instance, the neck board that came with this. They did not. Well, yeah, they did. They changed the caps on this one. But they, for some reason, put the resistors on the backside of the neck board, and this is all, with all these, this is all jacked up here. The outside one's a little loose, so we'll have to fix that. But why are the resistors on the backside? Who knows? Things like that. And all the solder joints on all of the caps are horrible, absolutely horrible. So I'm gonna have to go through and just I'm gonna pull all these caps out and probably just redo the cap kit and put these caps in my container of caps over here that I have. I don't really know what you call it. It's you know, one of the trays of all the different parts. I don't know what it's called, organizer. I'll go through and put all these caps in there and use them as spares and put a fresh, nice, good cap kit in here because, like I say, a number of them weren't changed out. Then you also have, well, I'll show you that in a minute, but as far as like missing components, the only things I saw going over this is the B plus pot. There are 2 caps here that were either not installed or are missing. If we look here, C800 and C701, these 2 caps are missing. There's supposed to be caps there, so I don't know if those got taken out or forgot to get put in or what happened. So there's 2 caps, V-hole pot, B plus pot. Those are the only 4 components I see that are missing or not actively installed. Everything else appears to be complete. There are things like this that are casualties of being tossed in a parts pile and that kind of thing. So somebody has removed the flyback and put the wire back on, which you don't even need that wire. It's not necessary for operation, and it just causes confusion, and the left side of the screen goes black. If you ever change a flyback on one of these and you turn it back on and the left quarter of your screen is black compared to the rest, just take this wire out. You got this wire. This wire has to be routed through the ferrite core of the flyback in a specific way. If you get it backwards or don't do it correctly, the left quarter of your screen is black. So it's easier just to take this wire off. It's not necessary for it to work. So we'll just get rid of that as well. So I'm going to pull all the caps out, take this wire out, probably clean it up in the sink a little bit as best I can. But that's the only thing. Those 4 components are all the stuff that's missing. Now, the reason I'm going to pull all the caps out and redo the cap kit is because it's just not done very well. We'll zoom in here and look at a couple of things. So we can look at things like this. That's not good. That's pretty sloppy. Where was another issue? If we look, let me look this over here, because there's a number of spots that I noticed that were really bad. Like, look at this. What in the world is this? Yeah, like, that's, I don't know what's going on there. And then there was this one. Oh, and that's what I was looking for right there. This. I don't know what's up with that either. It doesn't really come through in the camera too. It's just like a lot of the solder work on this cap kit is subpar. So since I have to do a complete reflow anyway as part of the process, if and when we get this working, it's just going to be easier for me. Plus, I really don't like working on stuff that other people have worked on previously, because I don't know if they might have lifted a pad that I can't tell if the pad's lifted. You know, there could be a lifted pad that broke the pad. The pad could be broken off the trace, but it could still look like it's connected by the way they've soldered it in. So I don't like working on stuff that people have previously capped and worked on, because I don't know if they've caused an issue and you have to go back and check things out and all that kind of stuff. So, but that being said, I think what I'm going to do is probably, oh, one more thing I forgot. So this cap here, this 100 microfarad cap here for the power supply, they replaced, or in the power supply, they changed that as well, but they didn't solder it in. It's not even soldered in. So things like that, and that one is like, I don't even know what's going on there. So I might have just tried to tack it in and didn't even do that side. So things like that. That's why it's easier to just, I don't know about easier, but it's better. Just pull all these caps out, put a fresh new nice cap kit in here. That way I can verify if any pads are lifted, broken traces, all the caps are in the right position, nothing's backwards, or the right ratings in the right spots. All that, it's just going to be so much easier to do it that way. Then we know that if something is wrong on the backside, it's not any of that. R104 is secure and solder joints are good. So yeah, just wanted to do a quick overview here before I really did any work to it. So I'm going to go clean it as best I can, blow it all out. I'm going to probably do the neck board last, so we'll just set that aside. I'm not going to worry too much about that. I'll go ahead and get all this cleaned. I'll pull the caps out, inspect everything, and if there's anything that I find, I'll show it. If not, then we'll just start proceeding on with trying to troubleshoot things. So I'll probably go ahead and put the caps back in for the power supply section. You know what? I think maybe I'll just do the whole cap kit. Yeah, I'm going to cut away. When I come back, I'll have it cleaned. I've already got a video. I think the one previous to this one on the channel, I'll link it down below, of how the process I use to clean these. I'll clean this up, take all the old caps out, or all these caps out, do a fresh new cap kit, get everything installed, get it all cleaned up, get the reflow done. If I find anything amiss, I'll show it on camera. If not, I'll come back and have all that work done. Then we'll be ready to do the power supply testing. I'm going to have to put in a B+ pot. I got to put in a V-hold pot. We'll do the light bulb test, power supply testing. We'll get our B+ adjusted to the proper setting. I'll get this thing taken off of here, and then we'll go through and see what we're dealing with. Because like I say, everything is installed that should be, that I can tell. Yeah. So let me get all that done. There's not really much else to talk about or show because it's complete. I guess we can go ahead and try and test the HOT. Because we can do that. I can do all the work to it, then we can go through and test everything on the backside of all the rework. But out of curiosity, sheer curiosity, let's go ahead and just test the HOT now, because there's no real reason why we can't, or why we shouldn't, or why we don't want to. So diode mode and negative lead on the center pin, and should get a 0.45-ish voltage drop to each outer pin. 0.451 and 0.451. So HOT tests fine. And we can test R104 now. I say I'm going to do one thing and I do something different, but R104 should be between 10 to 13k ohm. It's supposed to be 10k ohm, but it'll operate between 10 to 13k. If it's somewhere close to 13k, you really should replace it, but and we're at 9.98, so that's perfect. Okay, well, okay, like I said, I'll go clean this and get the old caps out, get the new cap kit in, get the reflow done, and get this in a position where we can go ahead and start doing a light bulb test and other operational tests and checking things, and I'll have to put the 2 pots in and everything. So, all right, let me get that done. I'll come back and we'll see where we're at that point. Oh, and one other thing I forgot to mention was that there's no remote board or harness, but we've got that covered. Because in all of my travels and all my years, I have acquired a stockpile of stuff here, so that's not supposed to be in there. Okay, so I've actually got a whole bunch of actual harnesses here for just such an occasion. Do I have any more hiding down here anywhere? No. So, yeah, I mean, I've got 1, 2, 3, 4 harnesses. So harnesses aren't going to be a problem. And we can zip tie that one all together. So we've got a functional harness here. I'll just take these and put these, oh, I don't want to do that yet. And then as far as a remote board, we need one that has the H hold pot not installed, so there's one right here. So the H hold pot on the K7400, K7500 is actually on the chassis itself right there. On the U2000 and the U5000, it's on the remote board. So they use the same remote board, but with slight modifications. Let's see if I can locate one here. Yeah, so see, here's a 790. Here's a 718. So this is for U2000, U5000. This is for a 7400, 7500. And you can see here that there is a jumper. The layout of the boards look the same, but they're not. You can see that there's a jumper over here for this one as well as here. But on the 74, 7500 one, there's an extra jumper down here that's not on the 2000, 5000 one. So there's an extra jumper here because it connects different things to different places, and the layout isn't quite the same for the traces and things. So you cannot use one for the other. You cannot use a 74, 7500 or a P790 for a 718 or vice versa without some modification. You can modify this thing to make them work for the other, but it's a lot of hassle and headache. So if you got the right one, it's obviously we want to use the right one. But for instance, if we did not have one of these and I had to use this, I could modify this by cutting traces and adding jumpers and putting this jumper in onto this one, and oh, I dropped it. So it's possible. Maybe that might make a good video in the future, but for now, I'm not going to worry about that. I've got plenty of other. See, here is another 718 because there's no jumper across there. You can actually see here, this one is a 85X0429, and this one is a 85X0375. So that's a 375 also. So 2000, 5000, 74, 75. Here is a 74, 75 because it's a 65X0429. And I can hear you saying right now, well, you're missing all of the pots. Well, you're right, but that's okay. We'll find what we need. Here is another 74, 75 that is complete. There we go. We can use that one. Another 74, 75. That one's complete. We can use that one. Here is another one that we can use. That's from Paradise Arcade. La-di-da. What else is in here? A whole bunch of 7200 remote boards. That looks like that's about it. I even have a Henrix Polo one in here with a harness and everything. Yeah, I think that's all of them that I have. So a couple of U2000, U5000s, the rest are 7400, 7500. So it looks like you know, we're not going to have to modify anything. So let's just use this one. This one's nice and clean. This one's a bit dirty. Let's just use this one with this harness, which I'll have to zip tie up and everything. But yeah, so we now have everything that we need. So with that, let's get this thing all cleaned up and reworked and ready to do our light bulb test and further testing and troubleshooting. Well, and here we have it. All reflowed, new cap kit, nice and clean. I got the B+ pot replaced, or, well, I got a replacement installed. And you'll also notice that I have a flyback installed. Now, I have a box of half a dozen brand new flybacks for the 74, 7500. But in that box, I also had a factory one that I pulled from a 7500 that had been damaged in shipping, and it's over here in my parts closet. I think the whole right side of this thing is snapped off. So I salvaged various things from it, pots and flyback and other components. So I have a factory flyback in here. I wanted to use a factory one because as good as the replacements are, they are still kind of hit and miss even to this day. So there's no guarantee that you put it in there and it'll last for a day or 3 years. It's just, or 20 years. It's just a crapshoot. So because I actually had a assuming good one, and the chassis was a low-hour chassis because it didn't have a speck of dirt on it, and it was really unfortunate that it got damaged in shipping. So I'm pretty sure the flyback will be okay. So I wanted to use a factory one in place instead of one of the new reproductions, because those are still a bit of a crapshoot. So if you have an original one that's good, I would go with that. So that's what I did. Factory original replacement installed. Got a new B+ pot installed. Cap kit, full reflow. It's all clean. It's good to go. However, I did break the original shutdown pot because I wanted to cut the glue off to be able to adjust it to the 0.1 that it's supposed to be. So in preparation of being able to have to adjust that, I accidentally cracked it. So I had to go in my little parts bin here of spare parts for the 7400, 7500, and I was able to grab a replacement pot. It's a 10K ohm pot, and the B+ pot's a 1K ohm pot. So I got that replaced, so I'll be able to adjust that. I'm not sure what to set it to initially, so I put a adjustment on it of I think halfway, give or take, and a little bit more. So B+ pot is slightly, it's about 1 o'clock position for B+ and about 1 o'clock position for shutdown. So we'll see if it even fires up. If it doesn't, we'll adjust that and see what if that's our issue of it not turning on when we get to that point. But all the work is now done. The full reflow is complete. It's nice and clean. Get rid of that. It's nice and clean. Flux is gone. All the bad solder joints are repaired. Everything is good to go. So I want to go ahead and go over a few areas that need to be looked at whenever you do a reflow on these series of chassis. We'll start off with the video input header pins. If they haven't been touched or original, it's guaranteed that a couple of them are going to be cracked. So video input header pins are the first thing to reflow. Your yoke pins, so these two pins right here are for horizontal, and these two pins over here are for vertical. So you always want to reflow your yoke header pins as well. The remote header pins here and the neck board interconnect header pins here. So these sets of pins and these sets of pins here for remote board and neck board, those because when people put the connector on and off, they wiggle the pins and you can crack the solder joints on those. So these series and these series need to be reflowed, and they are very close together. So you want to make sure you have a nice fine tip on your iron and don't create any bridges. You want to ring all those for continuity to make sure you didn't create any bridges before you proceed on. So those are important to look at. Then you have the diodes in the power supply section. All of these high current diodes here, those solder joints like to get very dry and can crack. So you want to replace or reflow the solder on all those joints. So we got that done. The power input pins on every one of these I've ever worked on in my life that never got touched before I worked on it. All of these 3 pins here are dry and brittle and crack, because the connector gets wobbled around and through vibration of moving the cabinet around or the chassis around or the weight of the harness pulling on this wiggles back and forth and it cracks and breaks those joints. So you want to make sure you reflow those. You also want to make sure your flyback pins are nice and good, because those can crack and get dry as well over time. The vertical position transistor, this transistor right here is what controls your vertical position ability. If you have no vertical position adjustment, check the header or the header pins, the solder joints on that transistor, because they can get damaged and cracked and broken, especially the pads, because if this thing gets whacked or pushed when doing cap kits and stuff or connecting the cable for your remote board, that can get actually hit and damage and crack your traces for vertical position. Q703, this guy right here is responsible for your, how do I phrase this? Your horizontal drive. So the horizontal drive transistors right here run through Q703. So if this is faulty, you won't have any high horizontal output either. So the solder joints for that need checked. And the resistors by the drive transformer as well. So these two transistors get very hot, and the solder joints for those get very oxidized and thin and brittle, so you want to reflow those as well. And R104, I think that's about it. So R104, you'll notice here that This side was fine, but I did have to make a little bit of a repair to this because the pad was lifted slightly, so I scraped some of the trace away and just kind of beefed up that connection there, so this is nice and solid now. So other than that, that's about it. So all of those, other than those areas I pointed out, you want to make sure you hit all those definitely, and then after that go through and just hit anything that looks like it might need reflowed is the best advice that I can give. Otherwise, yeah, the main chassis is now done, ready for light bulb and power supply testing. I did not reinstall that black wire like I talked about because it's not needed for operation. And nothing's going to be damaged, or it's not going to, cause any issues by having that not hooked up. And it is nice and clean now. So if you look here, there were a few stubborn spots, but it's really nice and clean. Other than the heat damaged areas from years of operation, it's looking very nice and clean. Everything is good. Yep. So the main chassis, assuming there's nothing wrong with it, should be good. We know the HOT tested okay. So we tested R104. We can test our MOSFET, but I'm sure it's probably going to be okay. If you really only need to test the MOSFET and R104 when you're about to do a light bulb test or checking your power supply. If R104 checks within spec, then all this stuff's going to be fine. If any of this stuff is open or bad or shorted, then this won't read 10K. It'll read like 0. You can read a short across there. And MOSFET, the MOSFET reads okay and R104 is okay, then generally speaking 99% chance your power supply is going to be fine unless your switch mode power supply IC is faulty. That's the three most common issues with the faulty power supply is the switch mode power supply IC, the MOSFET, or R104 being out of spec. That's really all you really ever have to worry about on these, assuming your solder joints are all okay. But everything else turned out just fine. So let's go ahead and check the MOSFET, and then if it's good, we can lift L100 here and do our light bulb test and get our B+ set. So let's see. Looking at this, I realized here that I missed one joint here for the diodes. That's good. Okay, so let's grab our meter. Now, when you're testing this MOSFET, you're looking for a 0.5 voltage drop to one leg and then a 1.0 reading on the other. So I didn't mention it, but the MOSFET, the pads on the MOSFET like to vibrate loose and they can get lifted as well. So you might want to hit those. They look, when I did my initial pass through, they looked just fine. But I figure since we're going to go ahead and show this off, I might as well just reflow them anyway. So I've seen many times the chassis is dead, completely dead, because the MOSFET solder joints or the MOSFET pads for these three pads here are lifted and the traces are cracked or broken. So I've seen that many times. So we got a diode mode and we should get a 0.5 voltage drop to one leg here. Nope. There it is. Okay, so negative on the center lead, and then to the one towards the flyback, you get the 0.5 voltage drop. And then the one towards the other end by the transformer here, you should get 1.0. So there you go. So our MOSFET checks good. So we can lift one leg of the inductor out of circuit, which I think it's this right here. I probably could have done this before I cleaned the board, but that's all right. We'll clean it again afterward. Yep, that's it. Okay, let's lift that out of there. All right. So if this works, we'll move on to getting the neck board all reworked and done. And then once that's done, we should be ready to give it a try, assuming everything here works. So we'll clip on the heatsink for the vertical IC. We'll clip on to L100 there that's lifted out of the circuit. So basically, if you're new to the channel here, I haven't seen these before, by lifting this inductor here, L100 is the main output to the rest of the chassis here. So this area here that I'm covering up is all the horizontal output section and high voltage section. This right here is just the power supply. So by lifting this L100 out of the circuit, we're isolating the power supply output from the rest of the chassis. So you can lift that out of the circuit and turn this on and give it power, and none of this will energize. You're only testing the power supply. So you can run this just fine on the bench with power by lifting that out of there and connecting your light bulb here to that circuit for the proper load. Now this is a 8-watt LED bulb, which if I recall correctly, 8-watt, this 8-watt LED is equivalent to a 60-watt bulb. So we should be somewhat close to 117, but it's not exactly. So I'm going to set the B plus to 125 because this is not exactly a 60. Normally, if you use a 60-watt incandescent bulb, it's a complete, total, perfect analog to the CRT load. So if we use the actual 60-watt incandescent bulb and put this to 117, it would read 117-ish on the actual CRT when we're using that. But because this is not an exact analog to the 60-watt bulb, it's close to it, we're going to go to about 125 if this works. So we need to grab our meter, and we'll zoom out a little bit here. And we are looking for 125. We're going to hook up ground here for our negative lead for our meter. Right here. Positive lead, we can connect to the same L100. Go to volts DC. Grab power, and I do want to mention that it's always a good idea to squish these sockets together a little bit in here, because over time they can get spread out from faulty connections and things like that. So if you got a completely dead chassis, the easiest thing to test is to make sure you have good pin retention on the sockets here for your connector, and make sure the solder joints are good on the connector, because many times I've told people, hey, they say, hey, I got this dead 7400. I say, okay, grab the connector and push it and apply pressure to it. Does it fire up? Oh yeah, just fire it up. They let go and it dies. Well, that's because either these sockets are bad or the solder joints are bad. So keep that in mind. Okay, we are ready. Here we go. 1, 2, 3. We are not ready. You guys tried to trick me here. I forgot to plug it in. Now we're ready. I don't edit out mistakes. There's no reason to, so we all make mistakes. I get sidetracked very easily. So, all right, here we go. Now we're ready. 1, 2, 3. Yes, but we're 146. I don't know if you can read that. 146. Let's turn this down to about 125. Nope, I can't go down to 125. That's all the way down. So I don't know. I was under the assumption that this was more close to the proper analog to the CRT, but there's no way. Well, apparently 145 is, if I put this B plus pot dead center, it's 144. But regardless, either way, we have a functioning power supply, and you'll see here with this on the circuit still, it'll bleed it down. You don't really want to mess with it till it gets down to 0 or close to it. And if you want to, you can just take your lead here and go right to that. That'll discharge it immediately. You see, if I just put it right to ground, it goes right to 0, completely 0. So it's now discharged, and we can handle it safely, filter cap and stuff. So it's working. I swear I thought that this would get down to about 125, but I guess not. I don't know. Every time I use a different light bulb, I'm still going off the old numbers in my head. So either way. All right. So I think our main board is going to be good. It should at least turn on because our HOT is good. Reflow caps, power supply is good. Assuming our flyback, I didn't have a note on it. Some of the ones I have, like I have another one here. I got another one here that I had in the same box, and it says flash on contrast. So this is a factory one as well. So whenever you would adjust the contrast, the image would flash a bright white. And it turns out the flyback was faulty. So there's something in here that causes the blooming or screen to go just a bright flash of white whenever you try to adjust contrast, and it was this thing. So I held on to it, but yeah, things like that. So this one didn't have a note on it, so I'm assuming that this one's okay. But like I say, it came from one that was snapped in half, so I'm going to say it's probably okay. Let's make sure to not forget to put L100 back in, because I am notorious for forgetting that. I go through the hassle of hooking this all back up to a tube and turning it on, and it doesn't do anything because I forgot to put the output to the rest of the chassis back in. So, all right, let's clean that up real quick before I forget. And I think I also have to hit over here, yeah. And I like to use denatured alcohol when I clean these because it works so much better than regular IPA. And it leaves a bit less of a residue, so I like to use denatured alcohol as opposed to IPA. That's my personal preference, so you can use whatever you want, but I use the denatured alcohol. I'm just looking at a couple things here. All right, I think our main board's going to be good, unless it should at least power up, unless there's some type of, you know, horizontal oscillation issue or stuff like that. Hopefully this should be good. I mean, there's a reason why somebody gave up on it and robbed the flyback, and who knows what else. Maybe because they didn't put these two caps back in. I mean, why would you steal these two caps? I don't get it. So I think it's possible that maybe they forgot to put these two caps in and turned it on and it didn't work or had problems and they gave up. I have no idea. How does any chassis become a parts chassis? I don't know. But okay, I think our main board's fine. So we'll set this aside, and now we're going to have to see if we can work on this guy. That's our cap free. Actually, I need to pull all these down because we're going to have to use these caps here, and this one only uses 1, 2, 3, 4. So there's different versions. There's different revisions of these neck boards where it's like H, I, J, K, and some use a cap here, some use a cap here. This one doesn't. And I just heard a crack, and this one isn't even soldered in here. You can see, whoop. So whoever worked their magic on that main board also worked their magic on this one, and yeah, so either way. So we're only going to need 4 of the 10 microfarads and 1 of the 100 microfarads, so we'll put that there. And I'll put this away in the stash, and I'll put these away in the stash. Okay, so there we go. 6 caps to change. It's clean, so we don't need to clean it. We got to put these resistors back on the front. Why they're on the back, I don't know. We got to fix all of this here. So let's do that, and then we will hook this all up and see if this works. But for now, I got to go get me some lunch here because it's getting lunchtime and I need a break. And I'll come back here shortly and we'll work on this and get this done. Okay, so lunch has been had and reflow and rework has been done. I've done everything to this that needs to be done except for the rework on here, on these I should say, because I want to save those to show everybody how to do that. So I have successfully moved the resistors from the back side to the front side, and I've reworked all the solder joints here. These got all torn up because when you put them through this way, you try and pull them out, that just lifts the pads. So I have redone all of this, scraped away using the fiberglass pen, the traces, and bent the feet over and soldered right to the pad. So those are super secure now, ready to go. I see now that I've got a gap in the solder joint here somehow. There we go, that's better. Okay, so that's done. So I've also reflowed the other end here with all 3 of these connections. These 3 connections, we have removed the original transistors here, so we'll have to go through and figure out how to fix all this. I reflowed these 3 transistors here. It's important to get those. I've reflowed all of the adjustment pots, which will clean those as well, set those to where they need to be set. I have reflowed the header pins here for the interconnect cable, like I mentioned on the main board. And that's about it. Anything else and everything else that needs hit, you know, this joint here and this joint here and this joint here, these 3 need to be reflowed. Those are always dry. Ground, the G2 pin, everything that needs to be done has been done. The only thing left is to fix these transistors for the color, and we'll clean up these color pots here first. So I like to actually try and spray a little contact cleaner down inside of here. So just spray in the face of this. These are enclosed. They're not going to get any of that stuff inside. unless you try and spray this directly inside these contacts down here, that will help get that stuff in there. Then you can take your screwdriver here and just wipe it back and forth, back and forth, back and forth, because these like to get oxidized in there and they sit in one position for a long time, and you'll get color problems and you'll get issues where you barely turn it and the colors go wild all over the place. So I always like to spray down inside there, down where the legs are at, and just wipe these back and forth a number of times to clean them all up. That'll really aid in when you're adjusting these. So if you look down inside of here, you can see maybe there's a little gap in there where the contacts go inside the pot. That's where you want to spray these, down inside of here. Because if you spray the outside of this thing, you're not getting that stuff down in there at all. You're not doing anything. You're not accomplishing anything. I mean, you turn these back and forth, helps a little bit, but you're not really accomplishing any cleaning task by not getting this down inside of there. So this is what I do and what I recommend you do as well. And I'm just using this cheap electronics cleaner. You can get this from anywhere, really. I got this from, if I recall correctly, I got this from AutoZone when I was there getting some microfiber towels for cleaning the cars up. So, yeah. All right, so we've accomplished that. Now, I do want to say that these pots on these chassis don't like to be any higher than about a quarter turn. So when you set these, the two drive pots here, you can put those in about the center position, the nominal center position. But the bias pots don't like to be turned up any higher than about 1/4 turn. So if we turn these, let's see if I can get this, show this the best way here. So that's all the way down. Actually, let's see. Hang on, that should be all the way up. There's all the way down. So if we turn this about a quarter turn to roughly there, hang on, am I doing this right? Hang on. That's all the way down, that's all the way down, that's all the way down. Okay, I had that backwards. So what you want to do is turn this up to about a quarter turn. Anything higher, that's the baseline. The baseline is roughly about there. There and there. That's the baseline of where you want to set these pots to when you start off, and then you can adjust up or down from there, because anything higher than about this point, your colors begin to bleed. That's what I've discovered on these series of chassis. So that's where we'll leave it. And I've got all three of these transistors bent back slightly because you don't want them to be in contact with the actual heat sink, because that'll just make them hot and burn up and things like that. So yeah. Is that? I'm just hearing strange noises. Okay, so everything is now done and ready. We just need to fix these transistors. Everything looks okay. So now that they're out, let's start by, why does that always do that? I don't want this sticking out of here. Okay. You always pull the wrong one. Anyway. All right, so we need to clean the solder off of the legs here, because it makes it hard to get these through the holes when there's excess solder still chilling on the leg. So we'll just use a little bit of braid to clean these off. Okay, that should fit down through the holes nicely. And we'll just repeat that process for all three of these. And again, the whole reason for this is because these transistors get really hot and they damage and lift and break those traces from vibration and people handling them and trying to move them around and bend them, and it just pops those pads right off the board. So, you know, you can use a little super glue to try and hold them down, but ideally, if you install these properly, you won't necessarily have to do that. So we'll begin with, so the way this works, you've got red, Q505 is red, Q504 is green, and Q503 is blue. So it's red, green, blue. So if you're missing red, that transistor, missing green, this transistor, missing blue, this transistor. So, or color issues, I should say. So we'll just start by putting this back in, and hopefully it goes in fairly easily, okay? And we'll push it down as far down as it can go. You know, if it's touching the board, I mean, that's fine, but ideally you don't really want it to touch the board completely, although it will help transfer the heat or sink the heat away the more surface area you have. So if it's touching the board, that might actually help. But you also want to make sure that you don't actually touch these resistors. You want to position this where the heatsink is not actually in physical contact with either one of those resistors or these resistors back here, because that will induce heat upon those components and make them fail quicker. So we got that sitting absolutely perfectly. Now, as expected, we got to pull it back out because the pins did not go through the holes. So it's a never-ending struggle on trying to do this thing. So we'll lift it back up again a little bit, and that came right off. Awesome. So we will try and, okay, there we go. Now we got them through the holes, and we'll try and put this back on here, which is not going to be fun, but we'll get it. Okay, that's on there. All right, so now let's make sure we're still sitting the way it needs to be. I'll say right there. Okay, that's good. And now let's see if we can at least get one of these in position here. Okay. So I also do want to mention that whenever you work on these, always take these out. Even if your pads aren't lifted, traces are in good position, good shape, always take these out. I say always because even if the traces are in good shape and the pads aren't lifted, I can almost guarantee you that underneath the solder joint, the pads themselves will be oxidized and bad. So I highly recommend every time you work on one of these, pull these transistors out regardless of the condition of the traces and pads, because you're almost guaranteed to have a couple or three of these traces, or pads I should say, the pads that are oxidized and need to be cleaned and reflowed. Just my opinion, that's what I recommend doing. Now the other joints here, if you have this sitting flat, and see how it's nice and secure, you don't really need to use any type of, well, cyanoacrylate or anything to hold these traces down, because they will sit flat. If the heatsink and the transistor aren't wobbling and moving around, they will sit flat without needing to use any type of adhesive or anything. So if we just apply some solder to this and get that on there, we can hold this trace down with something here. And we don't need to really worry about using any type of adhesive. And the same thing with this one. And I don't like how that looks. That's better. Okay. So, with that being done, I mean, it's not that bad, but you can see here that the traces and pads aren't lifted anymore, for the most part. And if we see how secure this is, I mean, it doesn't even move. And as I'm wiggling, wobbling this around, we don't really see any movement out of those joints. Only thing moving is the actual heatsink on the transistor, because it's not quite secure on there. But So that's really all you have to do. You don't really have to glue them back down. If you install these correctly where they're flat and secure and don't wobble around, that's just the heatsink moving, not the transistor. You don't really have to worry about gluing them back in place. So I'm going to repeat this process with the next one here. If I can. Nope. It always pushes the pads off. Okay, so now this one is flat as it needs to be. And this one is not touching. I'm gonna twist it a bit. There we go, perfect, right there. Okay, now we can work this magic again. I mean, you can glue them down if you want to, but with this method that I'm using here and describing, it's not really necessary. Because if it's sitting flat, it's not going to wobble or move around on you. When you run into problems when people install these and they leave, you know, a 1/4 inch gap between the bottom of the heatsink and the board, that allows this to move all over the place. If you sit it flat against the board, or as flat as it can go against the board, then you negate that whole issue. There we go. So now we are good on that one, and that one's good, that one's good. So even if they do move around, because they're flat against the board, they're not going to pop those pads off anymore. So you can see how close, they're not actually on the board, but they're very close to the board. I mean, the problem you run into that causes all this in the first place is when people install these like that, when they're sitting off the board that far, and it allows it to sit here and go like this, and that's how those traces and pads get lifted. So we negate that by pushing this as far down as it can go. Sometimes you got to reposition it and show it who's boss here and all that jazz. Right there. Look at that. Can't get much better than that as far as alignment goes. And that is nice and secure. So last one here. That one laid down quite nicely there. This we won't even need to hold these ones down. Beautiful. And of course, if you have a really bad situation where you need to glue them down, go ahead and glue them down. But you can see there that I didn't need to glue any of those down. And let me clean it real quick. We'll assess after I clean it here. Again, I use denatured alcohol instead of isopropyl alcohol. It just cleans better, and all that jazz. Okay. The denatured alcohol takes care of the flux much better than isopropyl. That's what I really mean to say. But so you're not going to win any art contests or any kind of awards for this, but that's pretty good. I mean, they're not, well, I say that, but that looks like garbage there. That's a bit better. So as long as everything is secured and soldered in and it looks all right, that's what's important. So it's not going to be that big of a deal, but you can see here that all of these are perfectly aligned now and they're secure. That one is solid. That one is solid. That one is solid. So we are good to go. I think our neck board is now done. And all the rework that we need to accomplish is accomplished. And let's get this back together. And if this works, then the only thing that was wrong with this was a bunch of really bad solder joints from a previous cap kit attempt, a missing flyback, and a missing remote board and harness. I think if this fires up and operates with no other issues, that's all it is. Yeah, missing flyback, bunch of bad solder joints, missing caps that weren't replaced, caps that weren't soldered in all the way, and a missing remote board and harness. So let's see about getting this on here. G2 wire. That's a little loose for my liking. That is really loose, quite actually. It doesn't even stay on there. So let's see if we can give it a little bit of pressure and persuasion here. See if that helped at all. Oh yeah, fantastic. All right, nice crunch. Makes a nice crunch when you install it. So now we've got our focus wire. All right, neck board completely installed. I did wrangle this harness with some new zip ties. So let's install this. Make sure we install it the correct way. It goes like it's missing the little key pin in there, and the connector is a bit broken, but it should still work. So it needs to go on like this with the missing pin and to the right there. All right, that appears to all be connected properly. So there you have it, one fixed up 7500. Yet to be tested still, but yeah, so let me grab a tube and we'll see what happens. Okay, so we're all hooked up on a tube, 25-inch dedicated K7500. We got our anode, neck, yoke, ground, power, video, remote, all 7 hooked up, critical 7. We are set up to read our B+, the test point's right there on the little test point pin in front of that cap. And ground, we're just going to the frame here for the vertical IC. You can go to the DAG if you want, but it's all connected, and make sure you put your screw in, mounting screw, so it gets a nice ground to the frame, and should work. If this fires up and operates, I have a Cruisin' USA board hooked up that we're going to be using for video if it does work and operate. Have my screwdriver at the ready so we can adjust the B+ pot and then the shutdown pot if it does turn on, just to see what it reads. If it needs adjustment, which it probably will, I have no idea where it's going to be set to. I don't have, as I say this now, again, I don't edit stuff out if I make mistakes. I forgot now, I realize I forgot to hook up the width control transistor. If you do not have this hooked up, you will not have any horizontal size adjustment. The width here, right here, this width control, you'll have no adjustment. So yeah, we are ready. So I don't know if that flyback works. I assume it does. Let's see. 1, 2, 3. Fires up. 119, which we can adjust out. What kind of image do we have here? Nothing yet at all. Brightness. I see a little something. Hey, there we go. Brightness and contrast had to adjust. H-hold, we need to adjust our H-hold, which is that pot right there. And ta-da! Okay, let's get the, well, we're at 120 now. Let's adjust our B+ down to 117, which I'm going to turn that pot. Nice, we'll do 117.5. Fantastic. Fantastic. Okay, now let's move our test point to right here. Badik, badik. And we want to adjust the shutdown to 0.1. So we'll turn our shutdown pot. It's not moving. Shutdown pot's maxed out. We're still running. And it's not adjusting at all. Let's go the other way. Sometimes, I know for a fact you have to turn this quite a bit for it to really make any change. Now it's all the way to the left. I have moved the shutdown pot all the way to the left and all the way to the right, and it's not making any difference. That is quite interesting. Does that pot not work? Did I put another bad pot in? If that's the case, why isn't it shutting down? We'll have to look into that later. But we've got this going on. Not sure what that's about. Let me get the camera set up on the tripod and we'll make some adjustments here and see what we can make this look like. All right, I don't know what's going on with the shutdown pot. We'll have to dig into that. But it's interesting how I can go all the way to the right, max it out, all the way left and all the way down, and it doesn't make any difference. It's odd. So I guarantee you, all this craziness you're seeing, if I move, I'm gonna turn the light off here. If I move the screen position or the horizontal position to the right, watch what happens here. I've seen this before and I know what's gonna happen here. So H position, it should fix that, keep that from happening. Well, regardless, if it's over too far to the left or too far to the right, crazy things like that happen. We'll wait for this midway screen to, there you go. See how dark this is? If I move it to the right, see that? If it's too far to the left, you get crazy stuff like this, back to the right, and it clears up. So let's set this about right there. Let's move our width. We have width control, as you can see. So we'll put the width right there. Vertical position. We have vertical position. Let's do vertical size. Well, okay, all of our controls seem to be okay. Let's turn our contrast all the way down, brightness all the way down. We have no brightness control whatsoever. Nothing. Okay. Another oddity to try and figure out. Oh, sorry, hit the camera there. Let's turn up our screen pot here. Roughly, I'll say there. And let's turn brightness back up. Oh, that's contrast. Yeah, brightness, I have no brightness control. We'll have to troubleshoot that. Contrast, roughly there. Yeah, without brightness control, it's kind of dim. Let me see if I can't really get back here with it. It's hard to turn that screen pot. So let's adjust our focus here. Oh, nope, this flyback's no good. Nope, gonna have to change the flyback because the focus is right there. The focus is maxed out and that is blurry as all hell. That is blurry as all hell. And the focus is maxed out. If I turn it to the left slightly, it gets worse and worse and worse. So that flyback is no good, and that's the risk you run using an unknown flyback. So I'll have to put a new one in because focus is not able to be achieved with that flyback, which means the internal focus resistor is faulty. So that's unfortunate. We'll have to change that out when we troubleshoot the brightness control problem and the shutdown pot issue, but it works. We are too blue. Let's turn green up slightly. If I can here. That's better, okay. Yeah, if it wasn't for the no brightness control and the focus problem, I'd say that this is good. Indeed. Yeah, if it wasn't for the brightness issue and the focus. But yeah, it's just not focused at all. That's the best it gets with the focus pot cranked. So, all right, let's get it back off the tube, troubleshoot this no brightness problem, change the flyback, try and figure out this. Maybe I put a bad pot in there for the shutdown, but I wasn't getting any reading at all on that. And that just kind of mystifies me because if that pot wasn't working or is faulty, you would think it would go into shutdown, and I turned that all the way left and right, and I got nothing. And let's go back to, I know you can't see what I'm doing here, but okay, we're still at 117.4 for B+, so my meter's good, my leads are good. Back to the shutdown pot, and it's just a constant 0.003 volts. Yeah, I'm not sure this pot is even working properly. I don't know, we'll figure it out, but okay, at least it's working. Let's see if we can figure out the other issues here. Well, I found the problem with both of our issues, the no brightness control and the shutdown pot not seeming to adjust anything. The first problem there with no brightness control was absolutely, totally my fault. I had put C701 in backwards, something I have not done, and I can't tell you how long. So many cap kits and so many monitors, I have never put in a cap backwards in recent memory until today. So C701, I had put this cap in backwards. So I took the old one out, put a replacement in, and I put it in the right way this time. So I'll see if I can go back and show a snippet of the video earlier where I showed it where the negative is actually facing this way. But the negative should be facing this way. So yeah, I put that in backwards. So that's going to be the problem of our no brightness control. Usually R305, this resistor right here, this one, usually R305 is open. That's what causes no brightness control most of the time. But in this instance, C701 here was in backwards. And as I look at this, I want to adjust this sub brightness pot to about 75%. There we go. This guy right there is sub contrast needs to be about 75%. So we got that done. All right, so that's the cause of our no brightness control. So as far as the shutdown pot not being able to be adjusted, this Zener diode here, Z701, I think it's the anode, the side without the stripe, that was not in circuit. So basically we had no voltage on our test point. Let's zoom in a bit more. We had no voltage on our test point because that leg of the dial was out of circuit. Somehow, either when I did the cap kit or when the previous person did the cap kit, I'm pretty sure it wasn't me. So, I think probably the previous person, when they did the cap kit, when they changed this cap out, they used their braid or whatever to desolder the area to get the cap out and ended up lifting this leg out of circuit, which means that if that leg's out of circuit, we're not going to get anything through to this trace and pathway to our test point. So I got that leg soldered back in. I got C701 reinstalled the correct way, and I got a replacement flyback installed. So I went ahead and put the jumper here onto the pin. I spliced it together so it's not just through. Normally I just take that pin and take it out and solder the wire right through the board, but I kind of want to get away from that because for ease of removability, I'll start doing it this way from now on. So yeah, pretty sure those two issues are now resolved, and this should be good. So let's get it back on the tube one last time and see if that hypothesis turns out to be a theory. All right, so we're all hooked up, back on the tube, and let's go ahead and turn meter back on, volts DC, so we can see if we can adjust that and if the Zener diode being out of circuit caused. Now I'm pretty sure the reason it didn't shut down with turning that all the way left and right is because that dial was out of circuit. Now it may have emitted a little bit of X-rays, but I'm I don't know. If I drop dead tomorrow, you'll find out. But with that diode out of there, that definitely was probably the cause of our problem, not being able to adjust that. And with C701 being backwards, yeah, it didn't explode because there's not a lot of voltage going through it, but yeah, I'm pretty sure that's the cause of our brightness problem. So with it all hooked back up, let's see what happens now. 1, 2, 3. Okay. Let's make sure. Oh, turn it back off. I forgot to hook the board back up, and I gotta hook it up here. It's always something. Let's see if I can. The light's turned off here, so can't really see what I'm doing, but okay, it's back on. All right, let's try again here. 1, 2, 3. Okay, and let's make sure we still have an image here. We do. So let's see if we can now adjust our shutdown pot here. Yes, we're looking for 0.1. Boom, 0.1. Close enough? Okay. Oh, and well, the screen image changed there. 0.8 now, 0.9. Close enough. We'll call it good. Right, let's just say right there. Okay. And let's test B plus again. Make sure it's still 117 after our new flyback. And yep, still good. Okay, now the main thing here is, let's see if we have brightness control. We do, but it's not much, but that's about normal. You'll see here that, I don't know if you can even tell, that's all the way up. It's hard to tell. That's all the way down, up, down, up. Let's get a stagnant image on here, or static image, I should say. There we go. Okay, all the way up, down, up, down, up, down, up, down, up. So yeah, brightness control has been restored, so we're good there. All right. Yeah, let's get the camera set up on the tripod, adjust some colors and screen size, position, shape, and focus and stuff, and see how this final result turns out. Okay, so I'm going to turn this overhead light off. And yeah, it's way too blue. So let's get a little red in there. Let's turn the blue down a bit. That's much better. Okay, brightness down, up. Yeah, you can see the difference now, so we're good there. Contrast. H position. And we're way too wide. Let's get rid of our width. And that's good. Let's get rid of some of this height here. Vertical position. Right here. That's good. Let's fix this height again, roughly there. Alright, so we need to turn up our screen pot a little bit here. I always go that way, and that's not the way you should go. Not from here. Okay, right there, and turn our brightness down a little bit more. Ah, okay, good. And let's do some focus. Oh yeah, that's good right there. And well, there you have it. A fully repaired Wills Gardner K7500. There's a little bit of gouging in the corner, but not going to worry about that. Yeah, so we had a missing flyback. We had a bunch of bad solder joints on the partial cap kit. We had missing caps when it was originally worked on. We had a leg of the Zener diode 701 out of the circuit, which was causing no shutdown pot adjustment. And then I put that cap in backwards, which was my fault. I don't know, a couple of other things. You know, you've seen the video, you know what was wrong. So anyway, yeah, that's about it. So given that this is a new flyback, I'll let this run for a number of hours, make sure nothing explodes or blows up, because I'll probably end up selling this chassis because I don't need it. But yeah, after the burn-in process, if all goes well, I'll probably put this up for sale. So otherwise, thanks very much for watching. Hopefully you learned something. And I put that cap in backwards for the first time, and I cannot tell you how long that I've been doing that. So, or how long I've been doing this kind of work. I could probably count on one hand the number of times I put a cap in backwards in 19 years of doing this stuff. So, but it happens. I probably got distracted from a murder porn show I was watching over here about 48 hours on the computer while I was doing the works. So if you don't know what murder porn is, you can look it up. It's nothing bad, you know what I mean. It's the like Forensic Files and 48 Hours and To Catch a Killer, things like that, shows like that. Murder porn is a term coined by South Park. So anyway, yeah, there you go. Thanks again for watching. Hopefully you learned something. Like, share, and subscribe, and we'll see you next time.